Awesome. And we're back. Yay! I'm doing a talk where I can walk around. How good is that? Oh, I've missed this. I even wore like proper trousers and everything for once. Right. Hello, my name is Simon, and I'm going to be talking about solid principles, which you would think is one of those absolutely most basic things ever in programming in the modern age, but it's alarmed me just how few people necessarily follow them. My contact details are up there in the odd chance that anyone ever wants to talk to me ever again. My wife has refused the opportunity to take these down for some reason, but I've worked in an awful lot of places over the last 16 years. I've worked for a lot of different industries. I've done government, I've done little local companies. I was briefly one of those contractors that your mum always warned you about. And these days I work for Muller, who has still yet to provide me with my flaming free yogurt, and I will not let that go, Liam. So, my point is, I've seen a lot of code bases over the years. Some of them are good, some of them were good, a lot of them were bad. A lot of them were very, 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 very bad. And an awful lot of those problems could have been solved with a few basic principles, which I would hope that most of you are at least passingly familiar with, but in any case, these are the ones we're going to go with. It won't solve all the problems, but it might give you some sort of an idea. This is the gentleman who did not necessarily invent them, but he certainly popularised them. In at least one case being named after someone else, he definitely didn't invent that one, but he put them in an order and gave them a slightly funny name. This is Uncle Bob Martin. I recommend his books. They're awfully good, and he does a nice series of videos on coding practices that are also worth your time. Clever chappy all round, I'm sure. Never met him. These are our solid principles. Do you see what they did with the name there? Do you see? Yeah, it's funny, isn't it? Yeah. We'll go into each of these in detail in just a second. Why there has to be 5? Because everyone else today has been saying that there are 4 basic principles to this and 4 of that. I've gone 5. Because I'm one back. No, it's no special reason. But anyway, they're 4 nice, relatively easy to understand guiding principles, and that's what we're going to go through, one at a time. Now, when I say I work for Muller, I have a secret other job. I work here. That's right, my office is about there. Great view of Alderaan, used to have. Not so much anymore, but you get the idea. Lovely place, very nice. We are, you might say, in the manufacturing trade. We take in planets as our raw material, we convert them into radioactive dust. So if anyone has a few thousand million tons of radioactive dust they need, let us know, we have them. Also, Alderaan might not be, anyway. But we've had a few setbacks recently. Version 1 went out, wasn't such a success, we went into production, hit a few bugs. This is version 2 we're working on at the moment. And we're hoping that the solid principles will help us get through version 2 and actually survive production this time. Who knows? So first we need to gather some requirements as we talk through, the single responsibility principle. So let's have a walk through our various areas of the business inside our Death Star, as it's codenamed. We're going to make a targeting system. One of the core parts of our business, we are a mobile gun platform. Aiming at a thing is pretty much one of the 2 major things we do. So, these guys here, these are the targeters. In my slightly imaginary scenario, don't worry, I don't really work for on the Death Star, it's taller, just to reassure you. But in my imaginary scenario, these guys, they work on the targeting system. They watch the radar, which inexplicably works in space all day, and stick things on the list of potential things that we want to incinerate. Great. So what do they need? They need a couple of functions on our targeting system. Well, actually, they just want to add a new target. Right, good. They found a thing, it was on the radar, add it as a target, it's on the target list. Good. This guy is our Moody DBA. And now, I did mention that we are an evil organization, so we use Entity Framework. Because of course we do. So the Moody DBA said that we need a save changes function, because that's what Entity Framework requires. Good, fine. We'll stick that on there as well. No worries. Who else needs some stuff? Hello. Right, this lady here, don't be sexist, is the gunner. She needs a couple of things. She needs to decide what is the current target, and we want to see a list of the targets, stuff like that. We're interested in, of our list of potential targets, which is the one we're actually aiming the gun at. So, a couple more things. Get all the targets, and lock on a target, get the current target, so that she's got everything she needs to operate. These guys are the UI guys. They're on the other side of the pit of doom on the bridge of what's it called? The executor, I think it is. So they need to turn targets into something that can actually be rendered onto the screen. We are evil, so we have decided for raw HTML. We've got ourselves a generate HTML for everything function. Great. So I've been to all the important areas of the business. This is fine. I've got myself a great big class and it's got a whole load of stuff in it. This seems good. Everybody is happy. Everyone has what they want. What is the problem? What's gone wrong? Well, this is all well and good until we start moving into the maintenance period. Because what if we decide that we want to shift out of entity framework and into something else? What if we decide that we want to put Oracle in rather than SQL Server? What if the way that the targets are selected changes? What if we have change? You get the idea. The point is that any change to one of those functions doesn't just affect the area of the business that owns it, as it were. It affects all four, because this same class contains all four business areas code. So any small thing could go wrong. Every single time that we go into this code base and tamper with it contains the possibility of introducing error, because we're all human, except for Lord Vader, obviously. But anyway, the rest of us are all human. And who knows, you could put something in the constructor, there's all sorts of things that could go wrong. But instead of having one angry business area, you've got four now. Four. Then the large asthmatic boss with the black cloak will be popping by requesting an explanation as to why four business areas are unable to incinerate our enemies for the 30 seconds before they incinerate us back. So that's not terribly good. In fact, this principle is often misunderstood as being that a module should have only one job, but that's not entirely true. In fact, the rule is that every module should have only one reason to change. And business area is a good reason here to divide them up. There could be further subdivisions, who knows? But the point is that we want to divide them up so that any given change that's foreseeable in the future would require a change to only one module. That's the ideal. And this is how I might arbitrarily split them up. There may be other answers, but this will do nicely. We'll have something like a repository just for the targeters. That's great. They can get everything that's there at the moment and add a new one. So all we're concerned with is the getting and the setting of targets. We'll give him the save. We'll give her the lock on and get the current target. And we'll give these guys the generator, because there we go. That's just a render. And in fact, we've got the added bonus now that this is rather easy to test in isolation, because all you're doing is pushing targets in and getting HTML out. Marvelous. And then there you have four classes, all divided up fairly neatly. Now, any change pushed in by any one of those business areas will not result in a complete crash to everything. It'll just be one of those guys that wants you dead. And that's a quarter as difficult to deal with. So, all things are good. That's this one. The open-close principle. Ooh, we're blasting through this. Good. Open-close principle. That's our O. This is that a module should be closed to modification, open to extension, roughly, words to that effect, I think. So, let's have an example. This is an enemy ship. We want to blow this guy up. That's what we do. So we want to program a battle computer into one of our ships to fly around and blow this guy up. Fine. We need to put in a few rudimentary functions. We're going to fly, spin around, do a barrel roll because we're cool, and that's the sort of thing we do. That sort of thing. And that's marvelous. So we actually need to fight the X-Wing there. Let's pop in a function. Great. That means we detect an X-Wing, run this function, and presumably we blow it up. Good. That's all fine. What's wrong? What's wrong at this point? Well, it's an easy one. For anyone that's ever seen any of these films, there's an awful lot more enemy ships there. These are just three. There's more. That is a Y-wing, a B-wing, and a Millennium Falcon. I guess there's only the one. So we also need to blow all of these guys up potentially. So let's just stick in more functions for each one of these. Now there's an awful lot of problems here. I can think of at least two major ones. The first is, every single time then you'd identify another enemy ship, you've got to go into the battle computer, one of, again, our major business critical systems, because this is shipped onto all of our fighters, and any fault in this will result in all of our fighters being unable to blow up enemies, which is their major business driver. And that's a big problem. So adding in, and first off, we've got to reship all those DLLs. We have got to add in new code, which again could potentially introduce breaking changes, because it's always possible. Even if it's just something in the constructor, it could be shared code between private functions. There's all sorts of ways that adding in a new bit of code could break what's already there, and that's bad. And to be honest, we've got an awful lot of duplicated code here as well. That's not exactly on point here, but it is something we come across a lot with this sort of anti-pattern. I once worked for a company I shan't name because I think they'd rather I didn't, who had a system which had a set of rules which had to be used each year to do some printing of some letters, and the rules changed every year, but they also had to maintain all previous rule bases. So that meant all they did was literally duplicate all of the classes, paste them out, change the year name, make a few little changes, and then ship it. And that seemed good until someone realized that 8 years ago someone had made a very silly mistake. And everyone in every year subsequent had replicated that exact same error. Did I mention it was a desktop application? So it also had to be corrected 9 times over and then shipped to an awful lot of desktops. Painful, and the sort of thing we really shouldn't be having to deal with, especially on the battle computer of a starship. So how would we deal with this? Well, in my case, I would probably create an abstract class. Let's call it enemy fighter. This represents the bits that change every single time. What it means is we can do is write a single instance of the battle computer with a generic function, which is fight any old enemy ship. There is going to be probably like 90–95% of the time about the same stuff. Fly around a bit, dodge his weapons, shoot him when you got him in your sights. It's not that terribly difficult for a computer. But the point is, it's going to be roughly the same every time, so let's just leave holes there, like donuts. And these are the bits that are different that you customize for each ship. And then you create an abstract which fills in those blanks. And actually these are virtual, so presumably in my imaginary scenario, it's mostly the same every single time, and I've created a fairly broadly applicable set of rules in each of these scenarios. So you could do stuff like this. So now, creating a new kind of ship is as simple as we'll just add on a new class, which could potentially be in a new DLL if that's what we need to do. Just inherit off enemy fighter, and if everything base is fine, then that's exactly what we do. Millennium Falcon, for example, it must have a different rule about fire at where to shoot at it. So therefore we do an override. Great. And the same is true of however many other enemy ships we identify that we need to stick things in for. We just create a new instance of enemy fighter and create a new class inheriting off it and override anything that needs overriding, if anything, and often may not be. Simple. But the point is we never need to go into the original battle computer and modify it unless there is some sort of other significant change to the way that the code works. We can minimize the amount of expensive, dangerous change we make to our incredibly business critical system and just extend it without changing it. Easy. Why do people like to make things hard? So, there we go. We're just taking an enemy fighter into our battle computer and dealing with it in the abstract. And that should, in most cases, be absolutely fine. There are some exceptions, we'll get to that. Coming up, watch this space. So, this is the L. This is the Liskov Substitution principle. I think it should be more correctly called something like the Liskov Wing Substitution principle. I believe it was Barbara Liskov, not quite sure. But I think it was two ladies anyway that came up with this one, so this is quite clearly not the work of Uncle Bob, but fine. So, this is probably one of those where you hear the definition and you think, but it's not terribly difficult to understand really. And that is that something like any child module should be completely interchangeable with the parent without any consequences, roughly speaking. I'm paraphrasing. So let's see how this looks in practice. What does it look like? What can go wrong if you don't follow it? So this gentleman here is demonstrating for me a great big laser rifle. I am going to imagine that we're writing some sort of bot, a literal bot, which will literally carry the gun and go and shoot some people for us. Okay. And we've got a couple of different kinds of blaster rifle. I shall demonstrate. Who's up for a bit of sound effects with for me? Anyone? Come on. All together now. 3, 2, 1. No! You guys suck. You just don't want to play. Right. Anyway, we got two different kinds. A DLT-80. I'm not enough of a Star Wars fan to actually know this stuff, but I looked it up on like Wikipedia. It literally is called that, by the way. Wikipedia. Yeah. See what they did there. Yeah. But anyway, two different blasters. But this is fine. There is actually nothing wrong here. I believe. Yeah. There we go. We can create an interface. So we've got two functions, and that basically makes sense. There is no problem. You take your rifle, you aim it, and you fire. Or in fact, activate, which is fine. We're abstracting away the concept of a trigger because who knows? That is fine. You aim, you activate, whatever you are aiming at presumably is killed instantly. That is the ideal. There's no problem with what we're seeing. But, how about now? Does this seem entirely reasonable? There is a little bit of a problem here. You see, the lightsaber can conform to the interface. There's no problem with that. It has an activation. It's a button. Like that. See, that's how you do it, folks. And it can aim. Like so. But let's say, with the blaster rifle, say that there was a large enraged Wookiee over there, and he's charging towards me, wishing to eviscerate me. Well, with the blaster rifle, it's fine. I aim, I activate, he dies. There's no problem. What happens if the enraged Wookiee is heading this way and I have the lightsaber and I attempt to follow the same process? I aim, I activate. Well, that's not doing anything, is it? He's just going to run around and eviscerate me. So even though the interface can be implemented, it's not actually appropriate. You're getting behavior which is inexplicable in the lightsaber, even though it can implement it. So this would break the Liskov substitution principle. We've got a child class that behaves inexplicably given the same interface. So we can't really be doing that. I mean, you could, if you wanted, in the class that contains this, have like ifs based on types. If it's lightsaber, then maybe swish it around a bit rather than trying to just pull the trigger and assume that the job is done. That's terrible code, though. That is just asking for trouble. I've seen people who do that sort of thing. I have workplaces like that, and you end up with code that looks like spaghetti. It's not nice, and you shouldn't do it. This is instead how I might consider solving this problem. So, create an entirely different abstract class of weapon. I'll call it melee weapon. And to be honest, I could probably have shared activate weapon between all of these with, I don't know, activatable weapon or something like that. That would have been fine. I would have had no problem with that. But fine, this is good. But the point is that you don't, even though you could treat the lightsaber like a gun, you shouldn't. It has its own systems of behavior, and we have our own different abstract that we can apply it to create a different branch of code then based, again, on abstracts, though. Because this same abstract will apply, say, I don't know, to a sword or various other kinds of melee weapon. And this to me makes a lot more sense. And we're still not tying ourselves down to a concrete implementation of melee weapon. That's still abstract, so that is fine. Let's make, ooh, we are blasting through this. Okie dokie. I think we might be out for an early finish. The interface segregation principle. So, this one is the idea that we shouldn't have a function on our interface which the child class itself can't actually do anything with. So, returning to our battle computer. Let's imagine we've got a new order in. We don't necessarily want to destroy every single starship which comes our way. Instead, once in a while, we might actually want to capture them to bring them home and interrogate them and squeeze secrets out of them. It's the sort of thing we might like to do. So, new requirement, that's fine. This is a legitimate reason to modify our battle computer. We have an entirely new branch of functionality, so great. We're going to go in and disable their hyperdrive, making it impossible for them to blast away at incredible speeds and escape us before we can grab them. Okay, this is fine. No worries. We are going to put in enemy fighter, which again is an abstract, and that's fine. And what have I done there? Yep, and inside our enemy fighter, we're going to stick in some a new function there, which is locate the hyperdrive, because it's going to be in a different location on every single flipping ship. And that's fine. We can write, once again, an abstract, which is a general method of locating and destroying a hyperdrive, but without having to be specific to each and every ship. That's still fine. But what about if we wanted to look into, say, a captured TIE fighter? The evil rebellion, because obviously they're the evil ones, you know, not us, or something. But let's imagine they have. A TIE fighter does not have a hyperdrive, and yet it is an enemy fighter. And we have a problem here once again. The problem is that we are forced now to include the locate hyperdrive function on something that doesn't have a hyperdrive. Now, you could just put no code in there, that would solve your problem, but at a higher level, you still have this expectation that the hyperdrive exists and something will actually happen of meaning when you locate it, when there isn't one. This doesn't make any sense at all. And so what you're going to end up with is, I'm not even sure what. You'll attempt to locate it, get no particular location back, and then, fa-foom, I'm not sure, you'll just shoot into open space or something. But the point is that we're going to get strange, inexplicable behavior when otherwise the code appears to compile just fine. And this isn't good either. And this is where we're supposed to segregate our interfaces. We're supposed to split them out based on stuff that's actually appropriate for their levels of abstraction. So we've got to create another level of abstraction to make this work. We'll have a base one, which is which has no hyperdrive, which we could actually do it the other way around if you wanted. I don't really care. It's not like any of this is real. But the point is that we're going to separate this out. Now, I know these aren't literally interfaces, but the same principle applies. But the point is that we've got one category now, and again, it's all about making sure that we deal things as categories, not as individual instances, but we've got two categories now. One which has a hyperdrive, one that doesn't. And that means, again, in the abstract, we can deal with it this way, and we can still add and extend this out with as many ships with and without hyperdrives, and it still all works, and it's fine. And we just add the additional function that's required for the enemy with hyperdrive there. Actually, that's probably why you want to do it that way around. So, that's fine. And then we can update our code base like this. X-Wing, Y-Wing, B-Wing, Millennium Falcon all have hyperdrives. So we give them that implementation, and the other one, we just give it the base, just the enemy fighter, the thing with no hyperdrive. So this means we can again, presumably then in that case, we won't bother trying to disable the hyperdrive. We'll either just incinerate them or whatever takes our fancy at the time. Okay. Dependency inversion. Now, I'm hoping we don't really need to talk about this one a great deal, because mostly in most modern programming languages this stuff's pretty much a given. Certainly if you work in .NET Core, then it works with this out of the box, but I'm aware there's an awful lot of other programming languages out there. I don't know how it works in Python. I'm not a Python developer, I'm a .NET developer. But anyway, and then there's you Java. Any Java guys in there? Any Java? Yeah, I thought I could smell that. Yeah, you and you're getting all of the features of object orientation before we did. Right, dependency inversion. So, why are we doing this? In this imaginary example, we are dealing with the main gun. Now, this is our other primary business feature, so this is incredibly important. Aiming a gigantic gun at a planet and then firing the damn thing and incinerating everybody. That's what we do for a business. So we've got, I don't know, I made this up completely, I think, but we've got a plasma converter in there. We're instantiating inside Coke. So I don't know, it's the sort of thing you do, I suppose. I suppose that's how these things work. And we've got various functions handing off this. But the problem is then, If we ever wanted to upgrade from a Type 42 to something else, then you've actually got to change the code. You've actually got to change the code of the gun. One of the two most important areas, again, of our business. Something that we don't really want to touch unless there's a really, really important reason to, because we could, stop the gun working. So how do you deal with this sort of problem? Well, you just create an abstract and then you pass it in. This means that whatever implementation of the gun we're actually using is being managed by a different area of the code, something maybe a bit less business critical, probably something at startup. Again, if you use .NET Core, this will seem pretty familiar, because that's exactly what this is. I'm not necessarily going to talk about things like inversion of control containers and all that sort of thing. Come talk to me if you're not familiar with these. I'm hoping that mostly everyone's up to speed on this. What are the other advantages here? Well, of course, testing. Testing's the big one, because now we can inject fakey versions of our interface and test it in isolation, which is marvelous. Because testing is the way forward if you want to have a working gun platform. And yeah, that's how you do it in .NET. Again, .NET Core, pretty self-explanatory, to be honest. So, is everyone good on these? Yeah. That's actually taken an awful lot quicker than I thought. I have gabbled through that. So the upside is you guys have an awful lot more free time than you anticipated. Unless we've got a load of questions, that's good too. I like questions. Can't always guarantee to give a good answer, but further reading. I would recommend certainly anything by Uncle Bob. He's the guy that came up with these ideas. Go to it. His Clean Code series, it's not entirely about this sort of idea, but it's a really good video series on all flipping aspects, even down to like the first one I think is on variable naming conventions, and even that's got some really nice ideas in it. So definitely I'd crack into any of these guys as a good starting place. He doesn't necessarily invent much of this stuff that he's talking about, but what he is very, very good at is sort of having a look at what's going on, taking a snapshot and sort of encapsulating what the thinking of the industry is. And that is definitely worth having a go. There's the old classic here, Design Patterns. That is a massive, massive, massive book. I wouldn't necessarily try reading that cover to cover, not if you wish to retain your sanity, but you could. I have a copy at home, but I only delve into it once in a while. It's quite dry reading. There's a slightly friendlier book over here. But to be honest, learn by doing is usually the best way with these things. And that's if you want to take it an extra level further with some design patterns. But wow, that really did take a lot. I have taught far too quickly. This went a lot slower when I did it at home. Okie dokie. Does anybody have any questions at this point? Oh, that's what I feel. Oh. No. Going once. Going. Oh.
What's the Death Star canteen like?
The Death Star canteen. That is a very good question. Terrible. If only they had yogurt. I think the place would be much, much improved with some yogurt and some milk. If only I knew of a place that we could get some from. Anybody else? Sir?
Yeah, follow-up question to your Liskov Substitution principle and interface segregation principle. Could you not, your example, break the interfaces up differently? Could you not use interface segregation principle to segregate out the things for the lightsaber? Where would you go one rather than the other?
Okay, I'm just repeating the question for the sake of the microphone here. So it's about my two examples on Liskov Substitution. Now, correct me if at any point I get this wrong. It's a fairly meaty question. So that's on my lightsaber one and the interface segregation. When would I go one? When would I don't know. Without having a good think, I'm not sure. This is one of these where you're getting more into the art than the science of the coding.
Those two.
Yeah, they do. I see what you mean. The problem is different, and that's why I separated them out that way. Yeah. With Liskov, the problem is that the behaviour would be different, and you'd have to put special cases in at a higher level in order to recognize. With the other one, it's that you've got a function that isn't actually appropriate. With Liskov, actually fundamentally, that class shouldn't be there at all. I think that's maybe it. So with Liskov, the lightsaber shouldn't be in that category whatsoever. It doesn't really share. I mean, maybe there's the activate the weapon, but honestly, we're getting into like ridiculous levels of why. But yeah, with Liskov, I think the idea there is that this doesn't belong into that category whatsoever. Like, you can't switch the one to the other without something very strange fundamentally happening. With integrated segregation, it's more like we've got a slightly separate diversion of this little aspect of the behavior, and we need to, but fundamentally they're still the same thing. The different kinds of starship are mostly the same and mostly going to behave exactly the same, with this one little exception on the side. Yeah, I see. There is, to be honest, there is some overlap between most of these guys, but with me at least, I think that's where I would go more Liskov than. But either way, the problems throughout most of these principles is largely down to where have you picked your abstraction and at what level, and how are you going to branch them. And we're just looking at sort of different ways of cutting the same problem, to some extent. Yeah, I'd agree with that. Yeah, so about how you group them. Are these things broadly the same with a little exception, or are these things really radically different and require entirely different ways of handling them? I think that would, I agree with that. Yeah. Okay, any more for any more? No, going once, going twice. Okie dokie, folks. Well, you've got not that bad actually, not that bad with questions. Okie dokie, you got yourselves about 20 minutes or so before we all need to be back in this same room. So thank you very much, folks.